Okay, we're back after lunch here. So what I'm going to do now is, instead of having our class tonight at 5 o'clock, I would have done this during class. I brought the final exam from CSCE 155E in spring 2018. And we're going to do it. We're going to do it together as a review here. There was some starter code provided at the time. This URL is no longer live. But I do have the files that were provided at that URL. Let's just go ahead and read the problem statement here, and then we'll go ahead and get into the code a little bit more. So in this final, we're going to implement and use a structure that represents a book in C. In particular, we're going to need to model the title, the author of the book, both the first name and the last name, the published year of the book, and off of Goodreads.com, I've pulled a bunch of ratings of the book, which are numerical values of 0 through 5, and so they can be floating point numbers, 4.5, 4.75, with 5 of course being the best. You will then write functions to support this structure, process a CSV file containing a collection of data, and produce various reports on the data. Starter code has been provided, and there is a bonus opportunity. The data file has the following format. The first line will be an integer indicating the number of records, just like in some of your assignments. Each subsequent line will contain a comma-separated value of the values listed above. We've also provided an example. We'll take a look at that in a second. You will design a C structure, book, to model that book as described above. And again, we've provided some starter code, both a header file and a source file. You may write any additional functions that you feel will assist you in this exercise, but you must place them into these files, so we can't go and separate them out into utilities files and stuff like that. And then you'll write a program, bookdriver.c, that takes in a file name as a command line argument and processes it. You will then need to print a collection of data sorted according to the following 3 orderings. So we're going to print out a report of all the books sorted by book title, then by book author, last name, first name, then by release year. So if we've got multiple books by the same author, then we'll go ahead and order them by release year, oldest to newest. Then we'll go ahead and then a third report based on the ratings, highest rated first and then lowest. The bonus that I gave the last year was to write code for an additional report to produce a report that uniquely lists all authors. So again, an author could have 3 or 4 books. We only want one listing of that author, along with the number of books that they've written and the average of all their books in that data file. Okay, so let's go ahead and take care of the basics first. We're probably going to want to start by, well, first of all, taking a look at the starter code that was provided to see if there's anything useful in there. And then we're going to want to define this structure over here. Right? And I will come back over here and refer back to these often. Okay. So first of all, let's take a look at the data. There are only 20 in this example, but you should be able to handle, we're going to write code to handle any number of them because this is just one example. We want to be able to handle any example, and in fact, when theoretically, if we turn this into the web grader, there would be several test cases run, each with a different number of books. Okay, but otherwise, there's a title. Right? There's the author, the first name, or in this case, the first initials, the last name, the year that it was released, and then the Goodreads rating, 4.62. Okay, and then there's one record per line. Let's go ahead and go over here to the book.h. First of all, we're given instructions that the structure should be named book. That's straightforward. We're also given a create book function, a book2string, and then a couple of comparators here, strong hints that we should be using these. First by author, then by year, title, ratings, by rating. We've got a deep copy of a string just probably for convenience. And then this nice utility function that we provided that basically splits up a string along a single delimiter. This will save us the need for using strtoke manually for ourselves. If we can go ahead and leverage this function, then we should be able to simplify a lot of our code. We've also got a function here to free up the result of splitting out a string. Note that it returns an array of strings. The last one here tells you how many tokens there were actually found in that split function. And then finally a print book array. We're given an array of books of size n. We want to print them out to the standard output. Okay. Again, a lot of these functions were provided. Some of them weren't, right? So the create book, the book to string, the comparators, right? However, the utility functions like the deep copy, the split, and the free string and the print book array, they all have been done for us. Okay. So let's go ahead and go back. First things first, we need to model the book. This gives us also the factory function down here that allows us to create a book. Really gives us a strong hint as to what we should be using. For example, a title, which is going to be a string, a first name, author, first name, char star, author, last name. And if I were doing this as a full assignment, I would probably want to split that out into another structure representing an author or a person. Right? Int release year. We're not keeping track of the whole date, we're just keeping track of the year, so we can use a single integer to do that. Double rating. So it was pretty straightforward, both from the description over here of what we had to model, as well as the strong hint here with the factory function. Okay. Let's go ahead and take care of a few of these first of all. Now that I've defined a structure, everything else can be defined here before we even start to process that file. So to create a book, we're going to have to make deep copies of the title, the author, and the last name. Fortunately, we gave that as a free, up here, where is it? We gave that as a free utility function, a deep copy, right? So what I need to do first, since this is returning a pointer to a new book structure, I need to go ahead and create a new book. And that's going to be a call to malloc. And how big is it? Well, it's size of book. Now normally you just say times n, where you're going to create n of them. We're only creating one, so you could go times 1, but it's just as simple to keep that as just size of. Right? And that's what we're eventually going to return. Now, the book here, in fact, if I go ahead and split this right, if we take a look at what defines a book, right, then it's title, author, author name, release year, rating. So I need to go ahead and make deep copies of each of these strings. The release year, I could just copy that over, as well as the rating, because those are just numbers. Right? I could just assign those values. So what would be wrong here, since this is a review and I'm walking you through it, what would probably be wrong here is saying that b.title is equal to title. This is wrong on 2 levels. The first reason that it's wrong is because it's going to be a shallow copy. That is the title string outside of the class and the title string structure. The title string outside of the structure and the title string inside of the structure that belongs to the structure, they end up being a reference to the same thing. So changes to one affect changes of affect the other. What I want instead is a deep copy. So let me go ahead and use that function here. There we go. There. Now the second level that it's wrong is I've got a pointer to a structure. When I've got a pointer to a structure, I need to use the arrow operator, not the dot operator. But otherwise that's going to be the same for the author, copy pasta, bad in general, but okay in this case, somewhat. And then release year is going to be equal to this release year, and rating is going to be equal to the rating that we're given as part of the input. And that's it. We've created a factory function to create new books. It's dynamically allocated, so we're returning a pointer to it. We'll want to make sure not to leak memory that way. I'll show you what I mean here in a second. Another way of doing this would have been to have like an initialization function, init book instead, where you didn't have to dynamically allocate the memory. Instead, you gave off, by reference, you gave that initialization function, you gave it a book that had already been created, and then it was responsible for setting those other values. Okay. All right. So, in fact, just as a review here, it's not required by the exam, from last year, but let's go ahead and do that. Right? So it would look like, instead of create book, it would be like init book. Right? It would still take all of these things, except for it would also take a book by reference. It needs to be by reference, because if it's by value, then changes to it in the local function are not reflected in the calling function. And it can't be const, because obviously we are going to be changing it. Go ahead and align everything up if you're like me and you like your code to be nice and aligned there. So instead of dynamically allocating it, all we have to do is set all of those things. And then we don't return anything anymore because it's a void function. Right? So there's an alternative where now we don't have to worry about memory leaking at all. And you could, you know, if you are able to do this in an exam and improve the design, go ahead and do it. Right? Next one would be book to string. So the trick I'm going to do here is the one that I showed in class, where we'll go ahead and create a temporary static local string. And I'll just call it temp. Let's say 1,000 characters. That's not that big. But that's not what we're going to return. In fact, we can't return statically allocated memory because it's on the stack. It'll be popped off the stack, and it's not going to be available to return. But I am going to use that temporarily because I'm going to use sprintf and format this. Let's say the title by, title would be a string, by last name, comma, first name, and then maybe in parentheses here, a year. Right? And if you want to make sure that it's for like, we're not going to have anything written by somebody in 980, but it just to ensure that there's that that space over there, you can put a 4 there. And then it's kind of superfluous. But this is going to be B title, B author last name, B author first name, B release year. Oh, and then I guess we should go with the rating, and it was called rating. Right. And again, because I've got const book star B, I'm using the arrow operator. Const here because I'm not going to be making any changes to the book. I'm just going to be reading its values so that I can print them out. Let's go ahead and put that in there, %.2f. Right? Oh, and then with sprintf, you need to, as a first argument there, this would be okay if I were using printf to print to the standard output, but I don't want to print to the standard output. I want to print to a temporary string, right? And then I can go ahead and, well, I could reuse that deep copy, right? I could return a deep copy of the temp string, right? And that's good enough. I don't need to clean up temp, because that's static. That'll be cleaned up when the stack frame is popped off, so that's perfectly fine. Let's go ahead and start taking care of the comparators here, because we're going to use them and bring them all together. So if I want to do it, let's do the simple one here first by title. So the first thing that you do in a pattern with the comparator is, of course, you need to typecast them, coerce them into the types that you're expecting them, in this case books. So const book star x is equal to const book star, and we'll typecast A. Likewise with y, casting B. Right? And now we can actually look at them and compare their titles. Since it's just by title, I'm just going to use return strcmp of x's title and y's title. Right? Pretty straightforward there. Nothing needs to be fancy here because we've already typecast them to become the structures. Those structures have strings, and so we'll go ahead and reuse strcmp. I did include the string library on this already, so we're good to go on that. Same pattern down here, right? By rating, and I forget what the order is, so let's go back over here. Goodreads, highest rated first. So let's just do a mental check here. Say a book that's rated 4 and a book that's rated 5. 5 should come first. So you could try to do that trick that I discussed. X rating minus y. Oops, rating right? An arrow here, and take the difference. Again, that doesn't work for a variety of reasons. First of all, it risks overflow and underflow when you've got large values. For floating point numbers, it's even worse because 1.5 minus 1, it's going to be 0.5, but that's going to get truncated to an integer. So it would end up being that that 1.5 and 1 are the same thing. I'm not going to do that. Right? Instead, I'm going to make a comparison. So if x has a lower rating, it should come second. So x and y, they're out of order. 4 and 5, they're out of order. And they're out of order, you need to return something positive. 1 is okay. Else if it goes the other way around, right? If x is greater than y, then they're in order, 5, 4. So I want to return something negative. Otherwise, I'll go ahead and return 0. Now, I've seen a lot of people, try to do equality with floating point numbers. So, for example, you could say that x is equal to, or x's rating is equal to y's rating, right? That's going to be very, very error prone. 1.0, take 1, divide it by 3, you'll get 0.333333 repeated forever. And in mathematics, if you add that 3 times to itself, you'll get 1. But in computers, you don't. You can get 1.000001 or 0.99999, depending on how it works, how the rounding works. So it's best to just say, well, if you can, just leave it alone. Right? Now, in a lot of your assignments or another exam or something where you got to look at two numbers, are they close enough? That's where you build in a tolerance. You take the absolute value of the difference between them, and if it's small enough, say less than some epsilon 0.000001, then for all intents and purposes they're the same thing, and you can say that they're equal. Right? You might be experiencing that in some of your homework right now. That's pretty good. Let's go with by author, then by year. So this is going to be a little bit more complicated because we have to break ties. With the other two, we didn't have to break ties. If they were ties, then it doesn't matter if you go a perfect 5.0 book and a perfect 5.0 book. We weren't given any more direction on which should come first. So it's okay if there's a tie there. With this one, we're going to order it first by last name. So let me go ahead and create a result, right? And I'm going to compare, first of all, you need to typecast them to get X and Y. I'm going to compare X's author's last name to Y's author's last name, right? And if if result is 0, then we need to break ties. Otherwise, if it's not 0, then what's one example here? Rowling comes before. Or I guess comes after Herbert, let's say. Herbert comes before Rowling in alphabetical order, in lexicographic order. So we've already made a determination, and so we would simply return result. Right? Otherwise, we've got a tiebreaker here, right? And so we look at their first name. Author's first name, Y's first name, right? And we make the same check. If result is 0, then we need to break yet another tie. Otherwise, we'll return result. Right? And I'm getting quite nested here. Just 2 nests here. 3, I guess, technically. That's a little bit much. There's probably a way that you can unroll this nesting. For a better design, I'll leave that as an exercise to you, though. If they've got the same last name, same first name, so J.K. Rowling, we want those 7 Harry Potter books, but we want them in order of release year. So let's go ahead and compare the release year. Right? And here I am going to do that trick. Return X's release year minus Y's release year. Right? This trick is a little bit safer in general, the difference trick that is. Well, one, it's integers, so we're not going to have the floating point issues that we have with the ratings. But also, unless you have a book that was published in the year 2 billion, you're not going to be facing much overflow. All of the books that we're going to be looking at are published in the last 1,000 years, and so the difference is going to be at most a few hundred, probably only a few dozen or so. So in this particular case, it's safe, unless you have some artificial data where you've got some futuristic book, or you've got a book that was written by the primordial organisms or whatever. You're not going to have that. We're not going to. We wouldn't throw something like that at you. But I do want to think about the order here. So if X was released in, say, 2000, and this was released in 1950, then it'll be a positive number. So that means that the difference would be 50, positive 50. So in other words, these would be out of order, right? And is that what we want? So let's go back here by release year, oldest to newest, right? So if it were 2000, right, minus 1950, that would be 50, right? This would be out of order, right? So oldest books, this is correct. If it were something published in 1950 and then 2000, right? Then if we reverse the order, then this would be equal to negative 50. Which means that they would be in order. And a 1950 book is going to be older than the 2000 book. So that looks good to me as well. Looks like those are all the functions that we were suggested to run or to implement. So I'm going to go ahead, and I don't know where I am here. I'm going to have to desktop. I think I'm in final review. Oops. There we go. So let me see if I can compile it at least. And that looks good. Again, that's just our book library, basically. We still need to take care of the book driver, okay? Far less code given here, but we can use any of the code that we've already written in that library, or any of the other code that was provided to us in that library. So the first thing we need to do is we need to open up this file and process it, right? Then process the file given as a command line argument, that is, right? So file f is equal to fopen. The first argument is always going to be argv of 0, but that's always going to be the executable file name. So argv of 1 is where the actual file name is. And we're going to be opening it up for reading, okay? I'm not going to hard code books.csv. I am going to test it using that because there are 20 books here, but I'm not going to hard code it for that. So let's see. What else were we given? I think we were given like a split function. Yep. Okay. And then a print book array, so we can print it out, right? So let me go ahead and start outlining what I'm going to do here. Open the file and process it, right? And subpart 1.2 is I'm going to process the first line. Remember, the first line there tells you how many records there are, so that we can set up memory for our book, right? Set up memory, right? Then part 1.3, right, this is 1.1, I guess. We are going to process the line, each line, creating books along the way, right? Once we've got that, then part 2, what we actually need to do is we need to sort them by book title, then print them out. Sort them by author, then print them, that last name, first name, then by release year, print them out, and then sorted by rating, highest to lowest. And we've already done all the work for that. We just need to bring it all together. So sort by title, sort 2, 3, sort, and print by author, year, and finally for sort, print by rating. Okay. So let's go ahead and go in order here. Let's process that first line. I'm going to need a temporary buffer, so char buff. Some of them were long lines. I don't know if any of them were over 100, but certainly none of them were over 1,000. So I'll go ahead and use that. I will have a I will get the first line. So forgets, reading it into the buffer at most 1,000 minus 1 characters from the file f. Right? Now I've got that integer there. I've got that like that 20 right there. So I need to convert that to an integer so that I can set up memory. So int n is equal to a to I of the buffer, right? And then I need to set up my, as a second part to that, I need to set up my memory. So, oops, capital B book of books equals char star, I'm sorry, not char star, book star. A call to malloc, however many bytes a book takes, times n of them, right? And then I'm going to process each line along the way. Now, I could use forgets and capture the return value and then keep going until it's not null, but I want to respect that first line. I only want to do 20 books here, or n books in general. So what I'm going to do is a traditional for loop. That'll also give me access to an index so that I can actually initialize the ith book. I is less than n, I plus plus. Right? And so I will go ahead and get the line, forgets, buff 1000f. Right? So I'm going to get the line. Now I need to split it up, right? It's got all those tokens. Right? So normally you would use strtoke, but to help you out on this exam, we provided a split function that takes care of all of that for you. So if you're given a free tool, go ahead and use it. Right? And I'll call it tokens. Right? Call split on the string that you want to split is going to be the buffer. The delimiter that you want to use is going to be the comma. And then we will need another integer here. We can't use n because we've already used it, but num tokens, right? Let's say, and int num tokens. Right? Now to pass that by reference, we're going to have to pass in a memory address, so we put an ampersand in front of it. We can do some rudimentary error checking here. If num tokens is not equal to, how many are we expecting again? We're expecting the title, first name, last name, year, and then rating. So we're expecting 5. If it's not equal to 5, then we can go ahead and say print an error, line %d does not have 5, or let's say that it has blank tokens instead of 5. Right? And the line here is going to be I. It's actually I plus 1, or actually plus 2 because we skipped that first line. And so I'll go ahead and put in a plus 2 there. And the num tokens. Right? Hopefully we wouldn't throw some malformed data at you, but just as a sanity check, I'm going to go ahead and make sure that I've got that. So now I've got those tokens, again, those 5 tokens. I'm going to go ahead and have to create a book here. So here's what we would have done with the original version that we were given. Book B is equal to create book, right? And that create book factory function required the title, the author, first name, last name, release year, and rating. And so we would pass in, tokens of 0, that's the title. Tokens of 1, that's the first name. Tokens of 2, that's the last name. I think, right? First name, last name, and this expects first name, last name in that order. Good. But the last 2 tokens are an integer and a double. So I need to use a to I on tokens of 3 and a to f on tokens of 4. Okay? Now that's, then of course, I'm just getting a pointer to that. So what I would have to do then is I would have to say that books sub I is equal to B. That's not going to work. In fact, let me go ahead and try to compile that and see what happens here. Right? It's going to complain about that. The thing on the left-hand side there is a regular old structure. The thing on the, left-hand side is a regular old structure. The right-hand side, however, is a reference to a structure. Right? It's telling us that the thing on the left-hand side is a book, but the thing on the right-hand side is a book star, a pointer. So one thing that you could do to make them compatible is to dereference the right-hand side. Right? And then let's go ahead and just print them out. Print without sorting. Right? And what was that called? I think we gave you that function. Print book array. There we go. Sorry. Print the book array of books, and how many of them are there? There are n of them. Let's go ahead and try to recompile that. That'll work. It won't. It won't complain about errors. In fact, I think it'll even run. oops, let's see. So we've got a segmentation fault here. Oh, that's what. I should have put in more error checking. Books.csv, right? We have to provide that as a command line argument. And there it is without any sorting up front, right? We go from Harry Potter and the Deathly Hallows down to Game of Thrones, right? And the first one was Harry Potter and the last one was Game of Thrones. So everything seems to be working, but there is a problem with this. In fact, if you ran valgrind with this, it would tell you that you're leaking a lot of, not a lot of memory, but some memory, right? And the point at which you're leaking it is right here. When you dereference this, basically what happens is the values are copied over, but the original, so we've got this pointer to this book over here. And so when we say that that thing is equal to this thing, everything gets copied over, but then we lose a pointer to this on the next iteration. This book originally that was created in CreateBook is lost. So if you want to, you can go ahead and free B, right? And now it'll work exactly the same, except there's no memory leaks now, okay? Otherwise, alternatively, the second thing that I did was that I added my own function. You're perfectly welcome to do this. I added my own function. Oops, where is it? Init. I guess I didn't add the, there we go. I didn't add the signature in the header file, but I should do that, and I should go ahead and provide some documentation here, right? If I had block selection mode, I just have not. I'm using Atom, and if I had block selection mode, I could have gotten rid of that really quickly, but I've not added that plugin yet. All right, so this initializes an existing book to the given values. All right, there we go. And so the alternative over here was to not use CreateBook. I'll go ahead and leave that in there, but instead would be to init book, right? And the exact same arguments here, except for the first argument is now going to be books savi, and there's still an error here, but I'll show you what. So again, it's going to complain about this because book savi is a regular old book, right? But it expects a book star, a book by reference. So put in an ampersand there, and it's perfectly happy with that, and it should run just as before. Okay, great. Now all we need to do is sort and print by title, right? So printf, there's some fancy ASCII art here, books by title. Right? There we go. And what I need to do is I need to sort them, so I'm going to use qsort. I'm going to be sorting books. There are n of them. Each one takes size of book bytes to represent. And by title is going to be, there's my comparator for title. Right? And then I'll print them out again. Let's make sure this works before we move on. There we go. So there's the original order. And then down here, it's by title. Now, it's not going to be like a real library where if you've got an article like a, an, or the, they're ignored, and this would actually be in the G section for Game of Thrones. We're not expecting that, all right? This is perfectly fine. But it goes from a Game of Thrones all the way down to Weird Sisters, right? By Terry Pratchett, 1988, etc., etc. Okay? Cut and paste, since we know it works, and change. But instead of by title, by author year. Right? And my comparator for that was by author year. There we go. And then finally by rating. I think it was called rating, but we'll go ahead and make sure. By rating, yep. Okay. There we go. So there's the original order. There's by title. We know that that worked. There's by author year, right? The oldest book that I have here is Clan of the Cave Bear in 1980, and then all the way up to, oh, sorry, this is by author year. Sorry, Orwell. There we go. Then Gibson, then Heinlein, Herbert is all together. Hubbard, Martin, Melville, Pratchett, all the way down to Rowling is the last one. Then by rating, it should be the highest first. So the highest rated book here is Harry Potter, 4.62, all the way down to Dianetics, 2.33. Okay. All right. So there is your final from last year. Looks like it took me 35 minutes to do this. If you were doing this in an exam situation, I would expect it to take the full 2 hours or so. If I had not been talking through it the entire time, it would only probably take me 25 minutes, maybe, or 20 minutes. Scale that up to what you think your pace is. Come in with, we are going to give you some starter code, but not necessarily every piece of starter code. You're more than welcome to bring in any chunk of code you've written throughout the semester, that we've given you throughout the semester, that you've used throughout the semester. Come with your own libraries already at hand so that you can bring those to bear to get things done quicker, right? So again, no class today at 5 o'clock because UNL is closed, but this is your review. Have a good week, have a good weekend. Good luck on the rest of your finals, and good luck on this final. Have a good day.